And so if you notice on your sheet, I have 3 questions at the start. And so this says we need to differentiate with respect to x. And so if you remember, what that means is I'm going to take a d dx of both sides. Or not both sides, sorry. I'm already jumping the gun. I'm just going to take a d dx. What that means is the derivative with respect to x. Okay? So what I'm going to do now is I'm going to look at the x cubed. What is the derivative of x cubed?
3x.
3x squared. Now what you're going to do is you're going to compare. Okay? You're going to compare this variable right here and this variable right here. If they match, you're done. If they don't, we got one step. I've got an x and an x. They match, you're done. Okay, now let's look at the next one. You've got an x and an x. They match. So this one, I'm going to take d dx. Now I'm going to go ahead and take the derivative of y cubed, sorry. And I already told you, what's the derivative of y cubed?
Yeah, that does
3y squared.
Oh, yeah, I got it.
So now what we're going to do is we're going to compare variables. Do those variables match?
No.
No. So this is what we're going to do. I'm going to add a dy divided by dx. And the question is, how do you know which one to add? And the answer is whatever variable you're taking the derivative of, that goes on the top, and dx will go on the bottom. With that in mind, I want you to try the third one.
Sorry.
Now, I've written something up on the board that may help you out.
I got that stuff. Does it have to be 4d over dx? Okay. I'll take it
What's the derivative of x right here? 1. Do variables match?
No. Yes. Yes.
Variables match here?
Yeah.
Yeah, you've got x's, so you're done with that one. So I'm going to put a plus sign. What's the derivative of 3y? 3. Do your variables match? No. So you need a dy over dx. So that is your answer. Okay? Now what this is going to lead us to is this is going to lead us to our next task, which is implicit differentiation. And so on your sheet you've got 4 guidelines. Now why it's important you get this down is because we're going to eventually look at related rates, and we're going to do that lab with the Tootsie Roll Pop. And that's actually some application as to where you actually use implicit differentiation. And so let's go ahead and just go through these 4 and then we'll look at an example. First step is to differentiate both sides of the equation with respect to x, which is already what we did. Okay, on those first 3 we differentiated both sides with respect to x. Number 2, we're going to collect the dy dx terms on one side of the equation. Everything else will go to the other side. We're going to factor dy dx out of the side of the equation, and then we're going to solve for dy dx by division. So we're going to go ahead and do those 4 steps with this problem. It says find dy dx given that x squared plus y squared equals 1. So the first thing we need to do is differentiate both sides with respect to x, both sides of the equation. So this is where that d dx comes into play. So this is why we even looked at that very first slide, is so when we get to this step, we're going to be like, oh, that's not near as bad as what I thought it was. So that's the very first step. Differentiate both sides with respect to x. So what I could do is distribute the d dx to each, but I'm not going to because I think you'll be able to figure out. What's the derivative of x squared? 2x. Do your variables match? Yep. So you're done with that one. So I'm going to put a plus sign. What's the derivative of y squared? 2y. Do your variables match? So you need dy over dx. On the right side, what's the derivative of 1? 0. And your variables do match. Whenever you have a constant, they match, so you don't need anything else. Okay? So now, step 2. We differentiate both sides with respect to x. Step 2 says collect dy dx on one side, move everything else to the other. So I'm going to subtract 2x from both sides because I've already got the dy dx on the left side. Okay? So I have 2y dy dx equals what? Negative 2x. Now, step 3 says to factor dy dx out of the side of the equation. This is the thing. I don't need to factor it because there's only one term. If there's more than one term, that's when you factor it out. So I can actually jump to step 4, which is solve for dy dx by division. So I'm going to divide both sides by 2y. So I know that dy dx equals what? Negative x over y. And there you go. So if I wanted to evaluate this derivative at a specific point, like 1, 3, I could plug both the x and the y in and get my answer. So this is how you find the derivative with two variables. Okay. So we've got a few more. Here you go. You're going to do the exact same steps in the exact same order. So we're going to take d dx, both sides. So to save time and save some space, this is what I'm going to do. Okay, so tell me what I start with. Which is 3y squared. What do you get? dy dx. Very good. What do I get now?
Negative 2y times dy.
Okay.
And negative 2x
Negative what?
minus 5.
Yep.
Oh.
Okay, then minus 2x. And then what? Equals 0. Okay, now I'm just going to let you look at that, kind of make sure that you've got that down. What should my next step be? Add what? Move the 2x to the right side. Okay, because remember, our goal was to have all the dy dx's on one side of the equation. Okay, now I'm also going to do something else on this other step. I'm going to see if you see what I did. So, what did I do in that step? I went ahead and factored out the dy dx's to save you an extra step because obviously you can see that the dy dx's, they're already lined up there. So now to solve for dy dx, I'm just going to divide by 3y squared minus 2y minus 5. So your answer, dy dx, equals 2x over 3y squared minus 2y minus 5.
So you can things in the back.
You could plug the points. If you were to evaluate this at a given point, you would plug in your x and your y in there. Pretty self-explanatory. I think you've got 2 more. Don't you have 2 more?
No.
Okay, these aren't going to take us an incredibly long time, but we have to throw one in with the trig function. Okay? Hey, I'm going to change this to a sine y. Sorry. I typed that wrong. Sorry, that was my mistake. Okay, what's the derivative of sine y?
Cosine.
Cosine y dy dx. And that's going to equal 0. Okay. So what do you do now? Divide by cosine. So what do you get dy dx to equal?
0.
Which is just 0. Okay? Questions? Oops, let's go back. All right, this one's a doozy, so get ready. ddx. All right, so now, what's the derivative of x squared?
2x.
2x. Now, this is where it gets interesting, so you gotta be ready. Minus. You gotta use the product rule here. Okay, so I'm gonna put a minus 2, and then I'm gonna put parentheses because I'm gonna use the product rule for x, y. Okay, so basically, I'm gonna put a little note down here so that when we go through this one, you can figure out where those come from. So those are my 2 terms, x and y. Product rule states you're going to take first times derivative of your second. Okay, so I'm going to take the first term, which is x. I'm going to take that times the derivative of y. What's the derivative of y? 1. Do your variables match?
Yes.
The variable
Oh, yeah.
x and y match? No, so that's where you need a dy dx because you took the derivative of y on that one. Okay. Now that was first times derivative of your second. Now you need to add to that your second, which is y, times the derivative of the first. What's the derivative of x? 1. Do your variables match?
Yes.
Yes, because you took the derivative of x, so x matches x. So that is the derivative with the product rule. Now on the right side, I have the derivative of y squared, which is what? 2y dy dx, because your variables don't match. Okay, so now, because that's the derivative of x and that's the derivative of
You just
y.
gotta distribute that -2 right into that.
Now you've got to distribute that -2. So before I do that, I'm going to write this as x dy dx plus y. Okay, so really I have 2x, and then what comes next? -2x dy dx minus 2y. So now our instructions are to collect the terms involving dy dx on one side. So I'm actually going to move my 2x to the right side. So I'm going to add 2x over here. And I'm going to move it over here. So So on the left side, you're left with 2x minus 2y. On the right side, I'm going to go ahead and factor out a dy dx at the same time, and I'm left with 2y plus 2x. Questions? Nope. What do you have to do? Divide by 2y plus 2x. Now I have a question for you. What do you notice?
Cancel out.
What cancels?
Two X's.
No, they don't. The 2y's and 2x.
Just the X and Y.
Nothing cancels out, it stays all.
What cancels out? Your 2's. So it leaves you with x minus y over y plus x. And that's going to equal your dy dx. Okay. Now, just a little tidbit of information. If we were to have moved the 2y to the left, and we were to have moved the 2x and the 2y to the right, so if we were basically to flip and move this over here, and move this one over here, and this one over here, your answer down here is going to be different by negative signs. Everything's going to be the opposite sign because of how you moved it. Okay, so your answer actually on the top would be y minus x over negative y plus negative x. Okay, they're both right. All right, so it's one of those things that understand if you got the same answer as somebody, with the exception of one of you having all opposite signs, you're both correct. Okay? All right, so this is what you need to do. Okay? So 1, 5, 6, 10, 21, 22, 32, and 35.
Just like,
So.